Given the following flight plan information, trip fuel is given, flight time is given, fuel in tanks is given to you, minimum, reserve fuel is given, taxi fuel is given. So first, trip fuel is 136 kg. Reserve fuel is 30% of trip. So 30% of trip fuel will be 30 into 136 divided by 100, 40.8, or let's say 41 kg. Okay, so trip fuel is 136, reserve fuel 41. Next, taxi fuel 3 kg. Okay, so total fuel on board. So total fuel will be equal to trip 136, reserve 41, and taxi 3, that is 180. In order to find fuel consumption, we will find out fuel, okay, trip fuel plus taxi fuel, that is 139 kg, divided by flight time 2.75 hours. So fuel consumption is 139 divided by 2.75, that is 50.54. So endurance will be what? Endurance will be fuel on board divided by fuel consumption rate. So 180 divided by 50.54, 180 divided by 50.54, that is 3 hours 33 minutes. 3 hours 33 minutes. So correct answer here is option Bravo, 3 hours 34 minutes. Next question, a scheduled flight of 3 hours estimated flight time is being planned. Calculate maximum mass of freight that may be allowed or loaded in this flight. So different values are given. So step 1, takeoff mass limitation, landing mass limitation, zero fuel mass limitation. In the takeoff mass limitation, you write the takeoff mass value 62,800. Landing mass limitation 54,900. Strip fuel, that is 10,200. Okay, so 54,900 plus 10,200 is 65,100. Zero fuel mass limitation 51,300 plus fuel on board, okay, at the time of takeoff on the runway. So fuel on board at the takeoff will be equal to your trip fuel, okay, it will be equal to your trip fuel, uh, and we have this value called fuel on board at ramp is 5,800 kg. Okay, so 10,200 minus 5,800 equals to 4,400. Okay, trip fuel demand is 10,200 kg. Okay, that is how much fuel we are going to require to fly for 3 hours. Currently on board we have only 5,800 kg. So additional 4,400 kg is required, right? So trip fuel plus this 4,400, so 10,200 plus 4,400 equals to 14,600, right? So I'm going to write 14,600 here plus 51,300, 65,900. So regulated takeoff mass equals to 62,800. Regulated takeoff mass equals to traffic load plus dry operating mass plus fuel on board. Dry operating mass is 34,960. 62,800 minus 34,960 plus 14,600, 49,560. 13,240. Now our traffic load is made up of different parts. It is made up of payload. Okay, it is made up of payload plus cargo. So 13,240 payload. How many passengers do we have here? We have 115 adult passengers, each weighing 84 kg. We have 6 children, each weighing 35. We have 13 standard baggage for each passenger, 13 kg. Total passengers 121 into 13. So 115 into 84, 9,660. 6 into 35, 210. 121 into 13, 1573. So 1573 plus 210 plus 9660 is 11,443. Then also add flight crew 2 into 85, in crew 3 into 75, 70, 3 into 170, 3 into 75, 225. That is 395. So 11,443 plus that is 11,838 plus cargo. So cargo will be equal to 13,240, 11,838 minus 11,838, 1,402. So 1,402, the closest option is option Charlie. Select that. Next. Question number 37 we will do. The baggage compartment floor loading limit is 650 kilogram per plus meter square per meter square. What is the maximum mass of baggage that can be placed in the baggage compartment on a pallet size of 0.8 meters by 0.8 meters, and the mass of pallet is 6 kg. So remember, floor loading limit, floor loading limit equals to mass of pallet plus mass of baggage that has to be moved divided by pallet area. So floor loading limit is 650 kilogram per meter square. Mass of pallet is 6 kg plus x divided by pallet area is 0.8 by 0.8. So 0.8 into 0.8. So 6 plus x will be equal to 650 into 0.8 into 0.8, 416. So x will be 416 minus 6. So that will be 410. Right? So delta will be the option. Next. Question number 38. An airplane of 1 lakh 10,000 kg, okay, has its center of gravity 22.6 meter aft of the datum. The CG limits are 18 meter to 22-meter aft of the datum. How much mass must be removed from a hole which is 30 meters away from the datum to bring the center of gravity to its midpoint? Okay, so the formula is mass to be moved multiplied by aeroplane mass equals to distance center of gravity is to be moved, correction, mass to be moved, mass of aircraft multiplied by distance center of gravity is to be moved equals to mass of the load that is to be moved multiplied by distance the load is to be moved. So mass of aircraft is 1 lakh 10,000 kg. Center of gravity moved. Now your center of gravity is 22.6. So let's say this is your aircraft. This is the datum of your aircraft, imaginary datum of your aircraft. The CG limits are the CG limits are 18 meter and 22 meter. So the forward limit is 18 meter, the aft limit is 22 meter. And currently the center of gravity is located at 22.6 meter, somewhere here, 22.6 meter. Now we have to bring the center of gravity within the limits, right? So distance center of gravity is to be moved. We have to move it to its midpoint position, that is from 22.6 to midpoint, that is 20. So the distance the CG is to be moved will be 22.6 minus 20, that is 2.6. Mass of load that is to be moved, let's find that out. Distance that mass of load is to be moved from 30 meters up of the datum to its midpoint. So 30 minus 20, again same thing. That mass is located at somewhere here, 30 meters away from the datum. So we have to bring it to the midpoint. So 30 minus 20 is 10. So mass of load will be equal to 11000 into 2.6 divided by 10. So 110,000 into 2.6 divided by 10 is 28,600. Okay, 28,600. So that is round. So this concludes the lecture. I hope you have understood all the questions I have answered. If you have any questions, let me know in the comment box. Thank you for your time.